All right. We're going to get started with our slideshow. I'm not there. Someone's in my place. So pay attention. Let's get through the lesson. We just started quizzes up through 4.3. So this is just like a review. All right, your Christmas final is coming up in less than a month. So it's time to get after that. First one, limit as x approaches infinity of 2x squared divided by 4 minus x squared. I'll give you 30 seconds or so to give this a shot. Try your best. Okay, you got to start remembering these things. Keep it quiet and give it a shot. All right, if you don't remember, as x approaches infinity, means that you're actually looking for the horizontal asymptotes. Okay, so you're actually looking for the horizontal asymptote. So the degree of the numerator is the same as the degree of the denominator. So if you remember anything at all about that, it should be leading coefficients of each one. Okay? So it should be leading coefficients. So the answer should be 2 over negative 1, or it should be negative 2. Okay? So hopefully you did all right on that one. Again, as x goes to infinity means you're looking for the horizontal asymptote. Degrees are the same. So it should be leading coefficients. Next. Vertical asymptotes at x equals. Okay, the following graph has vertical asymptotes. Obviously, this question isn't asking the limit. It's just asking for you to look at this graph. Okay? So look at the graph, and where do you have vertical asymptotes? Okay, remember, that's where you have some number over 0. All right? Okay. Yeah, hopefully you factored it, used your quadratic, whatever. Came up with 2 and negative 1. So they both were going to be vertical asymptotes at x equals 2 and x equals negative 1. Okay? All right. Again, we're talking about the graphing methods today that we talked about yesterday. Recognizing domain is one of the main things to do. Classifying discontinuities as either vertical asymptote, hole in the graph, or a jump in the graph, and be able to find those. Intercepts, x and y. Obviously, when x equals 0, you're looking for y. And when y equals 0, you're looking for the x-intercept. So finding those intercepts is kind of important. You have to label those on your graphs. Symmetry, is it even or odd? We talked about those yesterday. Even symmetry is reflective over the y-axis. Odd is reflective over the origin. So make sure we have that written down. Critical numbers are first degree or first derivative, where the derivative is undefined or equals 0. And those gives you max and mins and cusps and points of interest. Concavity or PIs is second derivative equals 0. And that gives you intervals of concavity. It also can give you a max and a min. And these are things that you have to be able to do in order to answer the word problems coming down in your near future. So, yeah, you're going to be graphing some of those out to find intervals of where volume and area and things like that are maximized. Very big topic and hobby, and especially business calc, when you're looking for the maximum marginal profit and things like that. All right. Asymptotes also have to be labeled vertical, oblique, horizontal. Don't forget those are all very important as well. All right, let's get to the first one. Find the extrema and the points of inflection and sketch the graph of f. Okay, I'll give you a minute to write this down. You never know. There might be when there's a homework check, this one might be one of them. It's also a good idea to practice. Who's ever in my place, walk around the back of the room right now and make sure everybody's writing down what they're supposed to be writing down and paying attention. Quiz scores haven't been the best lately, so let's try to get those up today. All right? Vertical asymptotes. Where's that going to happen at? Correct. It makes the denominator equal 0 and the numerator not equal 0. That happens when x equals at 9/2. Very good. X-intercepts. Where's that going to happen at? Yeah, pretty much you're right. It's at 0. Okay? So it's also the y-intercept. You can only have one y-intercept on a graph. If you had more than one, you wouldn't be a function. And this is a function. You got multiple x-intercepts, but you only have one y-intercept. So the y-intercept's at the origin, the x-intercept's at the origin. We've got a vertical asymptote at 9/2. What about any horizontal asymptote? We just talked about that. Or is it oblique? Actually, it's not oblique because the degrees are the same. So you take the leading coefficient, which is 3, and then the denominator is 2 squared, so that's going to give you 4. So it should be at 3/4. Okay. Also, you can use your TI to help you in graphing these, but you still need the mathematics and the labels to sketch your graph. Okay, so we got x-intercepts, vertical asymptote, horizontal asymptote. We're in good shape. Okay. Critical numbers. We're going to take the derivative using the quotient rule. Derivative of the numerator divided by the derivative of the denominator. All right, so that's not going to be too difficult. Okay, so I'm going to use the quotient rule, so you just saw it flash up here. There it is again. Hopefully there's no typos in that. Excuse me. 6x times 2x minus 9 squared. That's the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. A lot of you are forgetting the derivative of the inside when you do that. You forgot that in your quiz. You need to make sure you take the derivative of the inside when you use the chain rule. And then you square the denominator. Obviously, 9/2 is not going to be a critical number. Okay? So you're looking at the numerator to find out where, if anything, it's going to equal 0. You can factor, you can multiply it out. I'd probably factor out the 2x minus 9 and factor out a 3x, or 6x actually. You can factor them both out. So you factor out the 6x and the 2x minus 9, leaves you with 2x minus 9, and also leaves you with a 2x. Okay? So it gives you, looks like a critical number at 0, and that's it. Okay. So the critical number is going to be at 0 when you multiply this all out and set it equals 0 and solve for x. So at the origin, it's either going to be max or min. And it's easy to tell that on the, since you have the derivative, it's easy to tell that on the left side of 0, the graph is going to be, if I put in like a -1, I'll have a negative divided by negative, so the graph will be increasing right there. And if I put it in, like a +1, it'll be a negative divided by negative. It'll still be a positive. Maybe 0 is not going to be a relative max or min. Maybe it's going to be a point of inflection. Okay? So it looks like 0 is a critical number, but it's not going to give us anything as far as what's going to happen with the increasing and decreasing. But you still list it as a possibility, something to take a look at. I put a -1, that'd be -2, -11, that'd be negative after a cubit. Oh, it'd be positive. So positive divided by negative, there we go. That's right. I didn't see this negative sign right here. So when you're at 0, you're going to have a negative right here. It's going to be going down. And a positive, so it looks like it's going to be a local minimum at 0, 0. Okay, so that's an extrema. That's something you want to think about and label in your work. All right, second derivative. Again, with the chain rule, it's not too bad because, you're just, oh yeah, I did simplify everything. I took the 2x minus 9 off right here. Hopefully you saw that. Right here. I took a 2x minus 9, I took that factor off, and made that a 3. Okay? All right. Now we're moving on. I don't want to end the show yet. I've got too much to do. Okay. Now I'm going to take the derivative. Again, using the quotient rule and the chain rule. So we're in pretty good shape as far as that. Again, factoring is probably going to be a nice one. Take out negative 54, a 2x minus 9 squared, and, you know, it's pretty easy to see how that's going to work. But it's not bad. I mean, it's not like you have trig functions and everything else running around. So, factor out negative 54, 2x minus 9 squared, leaves you with a negative 4x, so maybe a negative 9/4. Something's happening there. Okay. Again, I can cross off these factors right here. You know, so that's going to go away. That's going to knock it down to a 4. So then we'll have the negative 4x minus 9 up there. So we'll be in good shape. Okay. And that'll give me something at negative 9/4, like we said earlier. So that gives me a PI. So I got one PI, one critical number, and that's the Y value. That's the function value at 112. Okay? So we got our critical numbers, PIs, x-intercepts, y-intercepts, vertical asymptote, and horizontal asymptote. And this is a big deal. This is a big problem. You got to have your sketch, you got to have your work. You got to have some degree of accuracy when you're putting this together. Okay, it's going to be a big deal. It's worth a lot of points, just like last year. It's a big deal, worth a lot of points. Okay, so there's the graph. You can use a TI to help you, but everything's labeled off to the side. You got the points right there. I'll give you a minute to try it down. I'll just be quiet for a minute. Okay, you can graph it out. All right. I mean, now you can read the graph a little bit more. You can see how it's concave up, right in through here. You can see how it's still concave up over here. Okay? You can see how it's concave down right here. You know, it's going down. It's going to bounce a little bit, become a little bit tangent, and it's going to go up. You can see at 0, 0, there's going to be a relative minimum. You know, because it goes like that. You got the vertical asymptotes, the oblique asymptote. Yeah, it crosses. You can cross a horizontal asymptote. It's fine. You can never, ever cross a vertical asymptote, though. Okay? So that's in good shape. Yeah, you got the sketch, you got the work, everything's fine. Okay? Yeah, it's going to be a little more involved, but you're also at a bigger level in math. Okay? There's a little bit more expectations. All right. Can I go on? How much time have I been talking? Oh, plenty. Heck, we got plenty of time. All right. Next. Simplify f of x and sketch the graph of f. Okay? So, this probably, I don't know how many slides we have left, but write this one down and start working on it. Yeah, you can factor the top at x minus 3, x plus 2. The bottom is also x minus 3 and x plus 1. So when you factor that, that tells you there's going to be, well, obviously there's going to be a hole in the graph at 3. And there's going to be a vertical asymptote at negative 1. The hole is going to be at 3, 5, 4, or 5/4, and the vertical asymptote is at x equals negative 1. So, and now you're down to just your basic garden variety rational algebraic function. Okay, so vertical asymptote at negative 1, hole in the graph at 3 and 5/4. Again, you cross off the factors just like taking a limit. Put 3 back in, you get 5/4. X-intercepts. That's obviously going to be negative 2. And then the y-intercept is obviously going to be at, when you put 0 in for x, the y-intercept is going to be at 0, yeah, 0, 2. Okay? Horizontal asymptote. The degrees are the same, so what would it be? Yeah, it should be at 1. Okay, good. On a roll. So you got most of it. You got everything from just looking at the graph. You got vertical asymptotes, holes, horizontals, x, y-intercept. All you need is some critical numbers and some PIs, and your graph's about done. It didn't take that long at all. Okay, it took less than 2 minutes to get that part of it. Okay? All right, let's keep going. Nothing better to do on a Tuesday afternoon than sketching some rational algebraic functions using critical numbers and points of inflection. Sounds like fun. All right, so here we go. I simplified the x minus 3 to take the first derivative. It's not that difficult. Just remember to subtract on the quotient rule, please, to subtract. And now you simplify everything. So x minus x is going to go away. 1 minus 2 is going to be a negative 1. Okay? So, no critical numbers. That means the graph is always going to be what? Any number I put in, okay, on here, okay, I have to make allowances that x cannot equal 3, okay, that's for the domain. You remember I told you your number line has to reflect your domain, and x can't equal negative 1, okay, negative 1. We know there's going to be a vertical asymptote here, and we know that there's going to be a hole in the graph there. So, oh, that's not good. So you use those just like critical numbers to find out whether it's increasing or decreasing. For instance, if I put in a negative 2, it's going to be a negative number, so it's going to be decreasing. If I put in 0, still going to be negative, still going to be decreasing. If I put in 5, still negative. So the graph is always going to be decreasing. Okay? The graph's always going to be decreasing. Now, all I got to do is see if there are any points of inflection. Okay? And we'll do that by taking the second derivative. Okay, so the derivative is negative for all x. We figured that out through our number line. Second derivative, again, 0, derivative negative 1 minus derivative of the numerator. And now it looks like we've got a PI. Okay. No, actually we don't, sorry. I saw the 2x. Wait a minute, that's not right. Is it? Just a minute. Might have to get some help from some people in the audience. 2x. Shouldn't that be 2x plus 2? So x equals negative 1, which can't happen because, oh, I see. If you cross this factor off with this factor, it leaves you with a 3. Didn't see that, sorry. My mistake. I was going to get there either way, it's fine. Okay? But just in case somebody else didn't see that, they crossed off the factor, or I crossed it off. I didn't put a line through there, though. I should have. So, that means the graph, if I put in a 0, it's going to be positive, it's concave up. If I put in a negative 2, it would be negative. Again, using the number line values, and this is going to be a 3. If I put in a 0, it's going to be concave up. And again, this comes from vertical asymptote. Your number line has to reflect your domain. Okay? It has to reflect your domain. If I put in a negative 5, that would be negative, so that would be concave down. Yes, vertical asymptotes change concavity just like points of inflection do. If I put it in 5, it would be concave up. Okay? So on both sides of the holograph, it's going to be concave up. And then on the other side of the vertical asymptote, it's going to be concave down. So, with that said, we just did that. We got the hole in the graph to worry about, but that's just going to show up as a blip right here in the graph. That's just going to be right here like a little hole. All right? And you'll be fine. Okay. And there's our graph. I'll give you a minute to write that down. We got the vertical, the horizontals, the x-intercept, the y-intercept, the hole in the graph, and it's always decreasing. And we got our concavity. And you can see that on both sides, -1. Okay? I don't know what else to show you. That's pretty much how you do it. Okay? Okay. To see if there's a crossing point between your vertical or horizontal and your function, set your equation for your horizontal asymptote at y equals 1 and set it equal to the function and see if it crosses. For instance, we'll go backwards and take a look. There we go. Set this function equal to 1. Okay? Cross multiply. You have x plus 2. I'm doing this with a mouse, so give me a break. X plus 2 equals x plus 1. Subtract x. Does 2 equal 1? The answer is no. So the graph does not cross this horizontal asymptote. Next thing I gotta do is set the horizontal or the oblique next to the function, solve it, and see if anything happens, okay? And if it doesn't, you're in good shape. If it does, not so bad. Okay? So get back to where I was. Okay. Page 206, 19 through 31 odd. Okay. 19 through 31 odd. Make sure you get that done. Start working in class. If you don't feel like working, just slowly start taking the letters off. O, D, D, and make it all, and it'll be due tomorrow. Okay? So they can work quietly with people, and they can stay odd. If you think the assignment's going to get a little out of hand, and they're not going to really work it hard, just make it evens. Okay? I want everybody to stay quiet. I want everybody to work. I'm giving you time. This is a lengthy assignment, so good luck with it, okay? All right. Make sure you show everything on your graphs. Either label it or off to the side. Thanks again, and I'll see you tomorrow. Have a great day.